Hello students. Today I explain the mathematics. Mathematics. Mathematics Unit 1. Vector differentiation and integration. Unit 2. Laplace transforms. Unit 3. Fourier series and transforms. Unit 4. PDE of first order. Unit 5. Second order of PDE and application. Today explaining of the Unit 1. Vector differentiation and integration. Syllabus. Vector differentiation. Gradient, directional, derivation, divergence, curval, scalar potential. Vector integration. Line integral, work done, area, surface and volume integration, vector integration. Theorems and Green's, Stokes and gases divergence theorem and problems on above theorems. Today class is gradient. Gradient increase or decrease in a magnitude. Uh, Some of the diagram, take the sum of the diagram in magnitude surrounding. Magnitude are increasing or decreasing depends upon the this called vector. Vector is a one direction, one magnitude. This value, take the sum of the one point, that's value of the phi x comma y comma z. Then depends on maximum rate of change. Gradient of scalar field statement. The gradient of scalar function phi is a vector. Its magnitude is equal to maximum rate of change of scalar function phi space variable whose direction is along that change. Grade phi equal to delta phi dou phi by dou n cap is equal to I d phi by dou phi by dou x plus j dou phi by dou y plus k dou phi by dou z. Prove this equation. Prove scalar field. Take the magnitude. This is the magnitude values. Take the sum of the values. Level surface. This value is constant value. Is the S1 surface, level surface 1, level surface 2. Differentiated in the level surface 1, define of one functions. Some of the functions including 1, 2, 3. This function is phi. This function is level is phi plus delta phi, d phi. Consider two level surfaces S1 and S2 very close together, characterized by the scalar functions phi plus d phi respectively. Let P and R be 2 points on level surfaces S1 and S2 respectively. Let R bar and R bar plus dr bar be position vector of P and R respectively relative to origin. Then PR equal to QR bar, minimum distance of the Q. Rate of increase of R in the direction PR equal to dou phi by dou R. Rate of increase of phi in the direction of P phi equal to dou phi by dou n. Grade phi equal to dou phi by dou n cap, taking dot product on both sides with respect to dr. grade phi dot d phi bar plus dou phi by dou n n cap dr. Grade phi dot dr bar is equal to dou phi by dou n dot dr cos theta. A dot b equal to a min block b block cos theta. Grade phi dot dr bar is equal to dou phi by dou n dr cos theta. Dr cos theta equal to dn. Grade phi dot dr bar equal to d phi by dn into dn. Substituting the dr cos theta dn placed. So dou phi by dou n by into dn cancel. Grade phi dot dr bar is equal to d phi equation 1. Now phi is equal to phi into x comma y comma z. Dou phi equal to dou phi by dou x dx plus dou phi by dou y dy plus dou phi by dou z dz. This is the formula. Dou phi is equal to dou phi by dou x I cap plus dou phi by dou y j cap plus dou by dou z k cap into dx I cap plus dy j cap plus dz k cap. Dou phi equal to d delta phi dot dr bar equation 2. Differentiate